Hello, I'm Dr. Harper. This video is in Supply Chain Analytics Inventory Homework Excel tutorial. And this is covering constant demand. So let's bring up a homework problem. So in this problem, here we have constant demand homework question. And here's the actual summary of the relationships. And so consider a constant demand of 3,040 items per year. Complete each statement. Now this problem may or may not, and the numbers may or may not be just like your homework. The numbers may be different, but the questions and the statements are the same. So complete each of these statements. So let's bring this up, and let's bring in Excel. Here we go. And let's bring this down here so we can use this, open this up a little bit, enlarge this a little bit. There we go. And then there again, this is constant demand. Oops. There we go. And so let's work through this problem. And as I go through it, I'll show you the relationships and how to work through the problem. Okay. Constant demand. First of all, let's the first thing we want to do is look at the demand. And so what we have here is constant demand of 3,040 a year. Okay, and so let's see. Right here, let's just make this a little larger here. And this is going to be the time. And this is going to be conversion. Okay, and the time is going to be per year. Then quarter. Keep hitting the wrong buttons here. Quarter, month, and then week. Good. And the conversions are going to be 1 year is the same as 4 quarters, 12 months, and 52 weeks. Good. Okay, let's go ahead and let's right justify these. And let's center justify these. There we go. Okay, and let's go ahead and box these in because we will want to box these in. Okay, now the demand up here is D equals per year it's 3040. So that's going to equal 3,040 divided by 4 is 760 a month. Per quarter. That equals 3040 divided by 12 is 253 1/3 a month. That equals 3040 divided by 52. And that's going to be almost 58.5 per year, per week. Okay, so there's the demand. Okay, now let's come down to here. Let's say, okay, for statement 1. Let's say statement 1. There we go. Now, what we have in statement 1 is the ROP of 86. Let's left justify this. There we go. So we have ROP is going to equal 86. There it is. And then the Q is going to equal 304. There you go. The lead time, let's bring this down a little bit more. The lead time equals 1.3, but it's weeks. So we come over here into weeks and say 1.3 weeks. Okay, so that's what we have. So let's box this in. So that's what is given. There we go. And what we want is the safety stock. What is the safety stock? So this is what we're after. Okay, now the safety stock is going to be pretty much the same for year, quarter, month, and week. Now we have 1.3 in weeks. So let's just bring this down. Okay, and now the safety stock is part of ROP. So let's come up here and say, well, ROP equals demand times lead time plus safety stock. Therefore, the safety stock is going to equal, let's see here, that's going to equal ROP minus demand times lead time. Just reversing that. And so this simply is going to equal the ROP, whoops, the equal, let me change that to minus. That's better. Okay, so this is simply going to equal the ROP, which is 86, minus my demand times my lead time. And there it is. And it's going to be 10. So the answer up here will be 10. Okay, so let's bring this out of the way. And this right here is going to be 10. Okay, now statement number 2. Let's complete this statement. For an inventory, okay, that's going to be statement 2. Okay, now for statement number 2, let's bring this up a little bit. The inventory policy is 1.2 months. Okay, that's T. T equals 1.2 months. That's going to be over here into months. 1.2 months. The lot size is 304 again. I'll put there under the same, under the 1.2 months, 304. The annual order frequency is what? Okay, frequency. Now the frequency simply equals 1 over T. Frequency equals 1 over T. Okay. So now that we have that, it's just going to be 1 over T equals 1 divided by T, which is 1.2. That's going to be that. But that is in months, and we want the annual order frequency. Okay. So, well, if it's 0.83 per month, then the frequency simply will be 0.83 times 12, which is 10 per year. And so again, this is going to be 10. And that's the answer to that one. Bring back Excel. Okay, so let's box this in. So there's the second one. Okay, there we go. And the answer was here. There we go. Now, let's bring it down to statement number 3. For an optimal inventory policy of, okay, let's bring this down, statement 3. And that's going to be the ROP is going to equal the 86. Now, notice this is the optimal inventory policy. So 173 is going to be EOQ. That equals 173. Okay. The inventory period is approximately how many weeks? So now we want the inventory period. T equals the inventory period. But we want weeks down here. Okay, well, then let's just bring this down. Equals this. And what's the inventory period? Well, now the inventory period simply is going to equal, let's come back up here, that's going to equal the Q over D. Q over D, okay? But our Q is EOQ over D, okay? And so let's come over here. That's going to equal EOQ, which is 173, divided by D. Okay, and that D is going to be in weeks. Divide that by demand per week. And that's going to be approximately 3. Approximately then, bring this out here, approximately 3 weeks. Okay, and so that's that one. So let's box that in because that's left justify. Box that in, that's our answer. Very good. Very good. Good. Now, statement number 4. For lead time, let's say statement 4 here. Okay. So now we have a lead time of 0.3 months, safety stock of 10, unit ordering cost of 120 per order, unit carrying cost of 650 per item per quarter, 120 per order per quarter. The total annual inventory cost for a minimum cost inventory policy is approximately what? Okay, we have more stuff going on here. The lead time is 0.3 months. Okay, so this is going to be the lead time equals 0.3 months. Which one's the months? Here's the months right here under, there's the months. So this is going to be 0.3. There we go. The safety stock is 10. So here we have the safety stock equals, put it under the number we have, 10. It'll be 10 will be for all of them. Okay, but we'll just put it there. Unit ordering cost of $128 per order. Okay, so this is C sub O equals, we'll put it under here again, 128 per order. It doesn't, 128 is for all of these. And a unit carrying cost of $6.50 per item per quarter now. Okay, C sub C equals per quarter. Let's see, quarter is this column D. The C sub C then is $6.50 per item per quarter. Okay, now the total annual inventory cost for a minimum cost policy is approximately. Okay, well, now for the total inventory cost, that's going to equal TOC, which is equal to the frequency times C sub O, TCC, which is equal to the Q over 2 plus safety stock times C sub C, and TIC equals TOC plus TCC. Whoops. Okay, now we need to do a number of things here. First of all, the C sub C here is under the quarters, and let's just bring it under months over here. Okay, well, when you change from a week, from a quarter, when you change convert the time units, I highly recommend go to a year. Okay, so this per year, 650 per year is going to equal this times the 4 quarters per year, which is 26, and then go back down to your month, which is 26 divided by 12. So it's going to be 2.166. So that's, I highly recommend that. Okay, now in order to get the frequency here, okay, let's bring this down. And the frequency simply is going to equal, it's 1 over T, but we don't have T. What we have is a lot. Oh, first thing we need is EOQ. EOQ equals the square root of 2 times D times C sub O divided by C sub C. Okay, we first need a lot size Q, and it says the minimum cost inventory policy, so that's going to be EOQ. So let's come over here and do it here. Equals the square root of 2 times my demand. My demand up here is going to be 253 1/3 times my ordering cost, 128, divided by my carrying cost. That's going to equal my EOQ, and there it is. Okay. Now that we have EOQ, now we bring this down and we need our frequency. Well, the frequency, if you recall, equals D over Q. But this is D over EOQ, because now we're working with EOQ. So that's simply going to equal our demand, which is this, divided by EOQ, which is this, and it's going to be approximately that per month. Okay, so now we can say, okay, now our ordering cost equals our frequency times our ordering cost, and that's 187. Okay, now our carrying cost is simply given by that, which will equal the EOQ, which is EOQ divided by 2 plus our safety stock in parentheses times the carrying cost, and it's 209. Then we add this together, equals this plus this is 396 and 52 cents. Okay, but they want the annual. Okay, well, again, to go to the annual, simply you take this. If this is how much it cost per month times the conversion here is 12, and you get approximately $4,758.25. So approximately right here, let's bring this back, is $47.58.25. Approximately $47.58.25. Okay, did I type that in right? I remember it. 47.58.25, and that's the answer. Yep, that's what they want. Okay. Now, having done that, we've completed each of these questions, but now we're sitting here with all this table here with a bunch of things not filled in. Well, we could fill all this in. Okay. First of all, this is going to be the same as this. This is the same as this, same as this. So that's going to be filled in. That's easy. The lead time, though, notice the lead time here, that can be filled in. But that filling it in, though, has to do with these conversion factors. Okay, so this will equal this divided by 52, and this will equal this times 4. This will equal my annual times 12. And I recommend doing that, going to the year and then going year to quarter, year to month, or going whatever, quarter, month, week, go to year, and then go to quarter, month, or week. And we can fill each one of these in. See, here's my inventory period of 1.2, and so that simply will equal, the annual will equal 1.2 divided by 12. This equals 1.2 times 4. Here we go. This equals 1.2 times 52. And there's 5.2. Q is the same. This will be the same. Okay. And 1 over T. This is 1 over T, 1 over that. Let's see, I have this. This equals 1 over T equals 1 over T. RP is the same, EOQ is the same, and T is going to be different. In other words, these are going to be all the same. Copy this down. Those are all the same. But this one's going to be different. Since it's 2.9 per week, then it's going to equal, this equals the weekly divided by 52, which is that much per year. So this equals this times the conversion, and this equals this times the conversion of 12 to months. And then this becomes a year per quarter or a week. Okay, and then we have this down here. We can certainly box this in, and here's where we begin solving it here. Box this in, and we could do the same thing here for all of these. Okay, and since we're here and since we're doing it, we might as well go ahead and do it. Can't, right? Because we know how to do it. So let's do it now. Instead of going back and forth, let me just take these down. Let me bring this down. let me just equals this. And just do it this way. Okay, now I can just use these and not go back up and forth, okay. So if the lead time is this per month, let's center these. Then we'll just say equals this divided by 12 equals this times 4 equals this times 52. The safety stock of 10 is the same. And also the ordering cost is the same. But then this is going to equal 26 divided by 52. Okay, 0.5. The carrying cost. Okay. EOQ is the same. That's not going to change. The frequency will change. Now the frequency here, again, this is going to be this. If you have 1 per month, then this is going to equal this times 12 for a year. And that equals this divided by 4 for a quarter. And that equals this divided by 52 for a week. And that's good. And then same here. This equals this times 12. This equals this times 12. This is going to equal this divided by 4. Equals this divided by 4. Equals this divided by 4. And finally, we have this divided by 52. This divided by 52. Now I'm doing this step by step. I'm sure you could probably do this a little bit more streamlined, but there's all the numbers. There's all the numbers that we can use as a reference. Okay, and so that's the answer to the constant demand problem. So that's all I have for this video. I hope this helps. We'll see you next time. Between now and the next time I see you, though, I want to urge everyone to be safe and take care.